For those of you working on Project 2, I put together a graphical user interface that may make it easier for you to make perturbations to your hull form. I'll put the code snippet up on the web or the My Courses site where the other final project information is. It's called shipcalcgui. GUI. Just a standalone single MATLAB code. shipcalcgui takes the same arguments or similar arguments to GenHull with one exception. You don't give a name to this because it doesn't actually output anything. It just gives you information on the screen that you can then use to make your final selection. So the outputs are length, beam, draft, the inputs, length, beam, draft, F0, F1, F2, F3, and the last input is different from GenHull. This is the center of gravity factor, the same thing I discussed in my other video tutorial, a means of setting the position of the center of gravity relative to the draft, such that 0.8 means that the CG is located 80% of the draft of the boat above the keel. A ZCG factor of 0 means the center of gravity is right at the water line, etc. So I do this and launch this, and of course I can do a help on this too. shipcalcgui. It gives you a little input about what to do, some examples. Maybe we'll just grab one of these here. I'll just grab this one right here. And we'll execute that. So it tells you what the inputs need to be. Execute. And it'll bring up a GUI. Now hopefully this will look okay on the monitors in the room. Sorry. I don't know for certain what the resolution of those are, but at least it looks okay on my screen. And this is the first GUI that I've made with MATLAB, so it's a little primitive, but I think it will work. So you see the sliders here will bring up the initial values that I set in that command, 240 meters, 32 meters, 14 meters, etc. This is the parameters. These are the coefficients that are the geometric coefficients that are calculated: block, prismatic, displacement, wetted area, the moment arm at 5 degrees in meters, the incident half angle in degrees, the length to displacement ratio, and length to beam ratio. So what I'm going to do is you can just slide at this point. Let's say I want to change F0, which is the coefficient again that changes the fullness of the form, the water line near the bow, and I'll slide this up and you'll see it gets more slender as we get towards the higher ranges of that. I'll put it back down again. If I change the coefficients here for the section, I'll get, I can change these values here to make the section more U-shaped. Excuse me, I'm using the wrong one. This is the buttocks one. To push more volume towards the end, this is the F2 coefficient. F3 coefficient is this section right here, which is going to make the sections more or less U-shaped, like this. So these were discussed in the previous video. I'm not going to spend too much time on that. This will reflect the geometric coefficients likewise. I'll put this code up on the web. What you're going to basically do is execute it, and you're going to execute this code and record these values here. Once you're done finding the parameters LBT and F0 through F3 that you desire, just write them down here and then go through the normal procedure with GenHull to generate the hull, calculate the resistance, etc. So this should just ease the process of coming up with the numbers that you need. But this doesn't actually save any data or do anything. It just plots to the screen along with these geometric parameters. You'll still have to take these values here, record them, on a piece of paper or something, and then go through the normal procedure.